Unit 41. The relationship between the angle of incidence and the angle of refraction. In the previous unit, we have known that the angle of incidence and the angle of refractions aren't equal. So does the angle of refraction change when increasing or decreasing the angle of incidence? The change of the angle of refraction following the angle of incidence. Using the covering method, draw the transmission line of light ray from air to glass or transparent plastic. Arrange the experiment as shown in figure 41.1. When the angle of incidence is equal to 60 degrees, place the eyes at the curved side of the piece of glass so that when seeing through the gap eye, we see A. Take the pin A prime to a position so that it obscures both the gap eye and the pin A. Prove that the line connecting positions A, I, A prime is the transmission line of light ray from pin A to the eye. Comment about the ray of light travels from air to glass. Indicate the incident ray, the refracted ray, the angle of incidence, and the angle of refraction. Measure the magnitude of the angle of refraction and write it into table 1. When the angle of incidence is equal to 45, 30, 0. Conduct an experiment following the above similar steps. Draw a ray of light travels from the pin to the eyes. In each case, measure the corresponding angles of refraction and write them into table 1. Angle of incidence, the refracted angle. Conclusion. When the ray of light travels from air to glass, the angle of refraction is smaller than the angle of incidence. The angle of incidence increases, the angle of refraction also increases. Page 112. People performed many experiments about the phenomenon of refraction when shining rays of light from air to different solid, liquid, transparent environments such as quartz, ice, water, alcohol, oils, etc. People say that the above conclusion is still right. Figure 41.2 shows that M is the place of the eye to see the image of a gravel in water. A is the real position of the gravel, B is the position of its image, PQ is the water surface. Draw the ray of light traveling from the gravel to the ice. In figure 41.3, SI is the incident ray. The refracted ray of this ray coincides with one of the lines IH, IE, IG, and IK. Add an arrow to that refracted ray. When the ray of light travels from air to different solid, liquid, transparent environments, the angle of refraction is smaller than the angle of incidence. When the angle of incidence increases, the angle of refraction also increases. When the angle of incidence is equal to 0, the angle of refraction is equal to 0. The ray of light isn't bent into section when it travels through two environments. You may not know. We used to think that when there is a ray of light shown to the boundary between different transparent environments, there will be a refracted ray. But some cases are not true like this. For example,